We'll start in 1 minute. Today we'll be in section 2.5 on how to solve linear inequalities. So we'll start with a definition. Inequality involves things that are not equal. So let's read this definition. If A and B are real numbers, such that A does not equal 0, then a linear equality in the variable x can be written in the following forms. So the one on the left, this is A times x plus B is greater than 0. So this means that a number that has the form A times x plus B is positive because it's greater than 0. The next one is similar, but a little bit different. A times x plus B is greater than or equal to 0. So in this inequality, A times x plus B could be positive, or it could be 0, since the inequality is greater than 0 or equal to 0. And then correspondingly, A times x plus B is less than 0. This means that A times x plus B is a negative number because it's less than 0. And then finally, A times x plus B is less than or equal to 0. So that the number A times x plus B is either negative or 0. Well, it's conventional, or we could say normal, to read equations and inequalities from left to right, just like we read from left to right in ordinary English. And so with that in mind, the greater than symbol looks like this. So the number on the left-hand side of this is greater than the number on the right-hand side. To the right, greater than or equal to, the symbol for that looks like this, greater than or equal. The less than symbol, and then the less than or equal to symbol looks like this. So in past semesters, sometimes students asked, well, how do you know what that means, or is there a way to remember what that means? One thing, if you think of, like in this greater than symbol, the arrow points to the smaller number. That's one way to do it, if there's any confusion. Or just constant repetition, so that you're constantly reminded of what those symbols mean. Okay, in the next exercise, let's translate the following statements from words to mathematical symbols. So this one, 5 is less than 11. Well, we can just write 5 and then use the less than symbol. and then write 11, and then 5 is less than 11. So you will probably agree with me that writing 5 less than 11 in symbols is more efficient than writing it all out in words. The next one, 18 is greater than 7. So write 18 on the left, the greater than symbol, and then 7. 18 is greater than 7. It will get a little more complicated. In this set of directions, it says translate the following statements from words to mathematical symbols and graph them on a number line. Okay, so this first one, a number x, is less than or equal to 3. So in symbols, we write x is less than or equal to 3. Okay, graph this on the number line. So we'll put a horizontal number line. We'll plot the number 3. And there are a couple of ways to graph this. One way is to put a solid dot at 3 to indicate the or equal to 3, and then color everything into the left. So on the number line, the smaller numbers are to the left. The larger numbers are to the right. So this is one way to graph x is less than or equal to 3. You'll encounter another way. I'll just put that also. Another way, instead of using a closed dot, use a bracket. So a bracket is a sort of a half of a rectangle. It has these 90-degree corners at the top and the bottom. And notice that it's opening to the less than side, so we shade to the left. Okay, the bracket at 3 indicates that 3 is part of that set of numbers. It's the or equal to 3 part in the inequality. And the solid dot represents the same thing as the bracket. In the next one, a number y is greater than or equal to 9. So in symbols, we write y is greater than or equal to 9. And we'll write down we'll graph the solution set in 2 ways. In both cases, we plot the number 9. If y is greater than or equal to 9, then on the number line, y could be at 9, so we put a solid dot at 9, or it could be to the right of 9. Larger numbers are to the right. And then the other way, put a bracket that opens to the larger side and shade to the right. Okay, the next one, a number w is less than 4. So in symbols, we write w is less than 4. We'll graph that set of numbers in 2 ways. So plot the number 4. That's the dividing point on the number line. If w is less than 4, this time we put an open circle to indicate that 4 is not part of the set. And then the numbers that are less are to the left. So this is the graph of the numbers that are less than 4. Using a parenthesis, the other way to graph this, put a parenthesis that opens to the left at the number 4 and shade to the left. So this parenthesis at 4 indicates that 4 is not part of the set. You can get as close to 4 from the left-hand side as you want. You know, for example, 3.99999. That's pretty close to 4. That's a number that's less than 4, but 4 itself is not in that set. Okay, the next one, a number m is less than 5 and greater than 1. Well, we could write this. We could write m is less than 5 and m is greater than 1. But we can write this more compactly. So the word and is used, so that means m has to satisfy both conditions at the same time. Not only must m be less than 5, it also must be greater than 1. So a more compact way to write this is to write 1 is less than m, and at the same time, m is less than 5. This bottom inequality is called a compound inequality. And reading it from left to right, we would just say 1 is less than m and m is less than 5. Or 1 is less than m, which is also less than 5. Notice the m greater than 1 is equivalent to writing 1 is less than m. Those mean the same thing. Do you see that? Okay, we can graph this set of numbers using the symbols. So this time we plot the numbers 1 and 5. If we use open circles, we put an open circle at 1, an open circle at 5, and then m is the number, or the numbers. M represents any number between 1 and 5. And then the other one we use parentheses instead of open circles. So we put a parenthesis at 1 opening to the right, a parenthesis at 5 that opens to the left, and then we shade in the numbers in between. Okay, let's look at the next one. A number n is greater than or equal to 6 and less than or equal to 10. So let's do this in stages. N is greater than or equal to 6. So n is greater than or equal to 6. And n is less than or equal to 10. And then the more compact way to write this, n is greater than or equal to 6 means the same thing as 6 is less than or equal to n. And at the same time, n is less than or equal to 10. So we call this a compound inequality because there are two inequalities in this statement. Okay, then graphically plot the numbers 6 and 10. We'll do it in the two ways. Okay, since 6 is less than or equal to n, we put a solid dot at 6. N is less than or equal to 10. And then we shade in the numbers in between. The other way to graph it is to use a bracket at 6, opening to the right, a bracket at 10, opening to the left, and then shading everything in between. Okay, we'll do a few more exercises involving inequalities and graphing them, but we'll also learn a new notation for inequalities. These inequalities that we've been writing, these are all algebraic notation. So algebraic notation involves the variable. So in each of those examples, each one of those, the inequalities are written by using algebraic notation. So algebraic notation always includes the variable. Okay, so the next page the title, Algebraic Notation, Graphs, and Interval Notation. Given an inequality in algebraic notation, graph it and then convert it to interval notation. Okay, so this one, x is greater than 3, that's the algebraic notation. If we graph it, we plot the number 3. And x greater than 3, we'll use the parenthesis opening to the right. The interval notation for this set of numbers, x greater than 3, well, for the interval notation, we're going to use a parenthesis that opens to the right. So in the interval notation, this parenthesis is what it corresponds to this parenthesis on the graph. Then we write the number 3 and followed by a comma. And on the number line, if you keep going to the right forever, you're headed towards positive infinity. So we use the infinity symbol. So this is the interval notation for all numbers that are greater than 3. Okay, the next one, x is less than or equal to 2. To graph this, plot the number 2, and we'll use a bracket that opens to the left, and the numbers less than 2, we shade those to the left. Okay, well, if on the number line we keep going to the left and never stop, we're in the negative infinity direction. So negative infinity, well, that's going to be on the left, so we put a parenthesis negative infinity, comma 2 with a bracket. We put a bracket next to the 2 because of the or equal to 2 in the inequality. So 2 is part of the set of numbers. And another convention is next to either infinity or negative infinity, we always use a parenthesis. We never use a bracket next to an infinity symbol, always a parenthesis. Okay, the next one, x is greater than or equal to 4. So we'll graph this, plot the number 4, put a bracket at 4 because of the or equal to 4, and then shade to the right. The interval notation, we use a bracket, 4, comma, infinity, parenthesis. So to me, the graph sort of resembles the interval notation in a way. For the interval notation, we always want smaller numbers to the left and larger numbers to the right. So the order of the numbers and symbols in interval notation corresponds to how we would graph. On a number line, the larger numbers are to the right and the smaller numbers are to the left. Okay, the next one, x is less than 5. Plot the number 5, put a parenthesis at 5 that opens to the left because the smaller numbers, the numbers less than 5 are to the left. So that's supposed to be a parenthesis. And then the interval notation for this, parenthesis, negative infinity, comma, 5, parenthesis. Okay, the next one, negative, this is a compound inequality. The next 4 are compound inequalities because each one has 2 inequalities. So negative 4 is less than x, which is less than 1. So we plot the numbers negative 4 and 1. So x is just a number that's between negative 4 and 1. So put a parenthesis at negative 4 that opens to the right, a parenthesis at 1 that opens to the left, and then shade the numbers in between. The interval notation, well, since the endpoints are not included, we put a parenthesis, negative 4, comma, 1, parenthesis. So once again, the parentheses next to the numbers indicate that they are excluded from the set of numbers. Okay, more of the same. So now it's just becoming monotonous, but we still do it for the practice. 3 is less than or equal to x, which is less than 6. So plot the number 3 and 6. Since 3 is less than or equal to x, we put a bracket at 3 that opens to the right. And at the same time, x is less than 6. So we put a parenthesis at 6 that opens to the left. And then we shade the numbers in between. Shade that part of the number line in between. The interval notation for this one is bracket 3, comma 6, parenthesis. Okay, the next one, 4 is less than x, and x is less than or equal to 9. So we plot the number 4 and plot the number 9. X or 4 is less than x, so parenthesis at 4, and x is less than or equal to 9, so we put a bracket at 9. Shade in between. Then the interval notation is parenthesis 4, comma 9, bracket. And finally, 5 is less than or equal to x, and at the same time, x is less than or equal to 11. On the number line, we plot the numbers 5 and 11. Put a bracket at 5 opening to the right, a bracket at 11 opening to the left, and we shade the part of the number line in between. And then the interval notation for this set of numbers is bracket 5, comma 11, bracket. Okay, now we'll start solving some inequalities on the next page. Solve each inequality. These are linear inequalities. Solving a linear inequality in one variable is very much like solving an equation. You just have to use the inequality instead of an equal sign. And another thing about solving linear inequalities, an important detail to remember, if you multiply both sides of the inequality by a negative number, you have to switch the inequality to its opposite. Also, if you divide both sides of an inequality by a negative number, you have to switch the inequality to its opposite. And we might have time a little bit later to explain why it works that way. But for now, let's just remember, if you multiply both sides of an inequality by a negative or divide both sides of an inequality by a negative, you must switch the inequality to its opposite. Well, on this first one, one way to start this, since we have -2 times the quantity 11 minus 6x is greater than 74, so -2 is a factor. It's a numerical factor on the left-hand side. We can start by dividing both sides by -2. It's not the only way to do it, but we can. So let's try it that way. Divide both sides by -2. I'll write it in some detail. -2 times 11 minus 6x. We're going to divide this by -2. On the right-hand side, 74 divided by -2. But remember what I said. If you divide both sides of an inequality by a negative, you have to switch the inequality to its opposite. So we're going to switch that to less than, since we're dividing both sides by -2. Okay, on the left-hand side, we get a cancellation. That's the purpose of dividing both sides by -2. -2 divided by -2 is +1. And on the right-hand side, well, we'll do that in the next step. So now on the left-hand side, we can write 11 minus 6x is less than negative 37 because 74 divided by negative 2 is negative 37. Okay, then we can proceed. We can subtract 11 from both sides. When we subtract 11 from both sides, we get negative 6x is less than negative 48. And then the last step, divide both sides by negative 6. So on the left-hand side, negative 6x divided by negative 6. On the right-hand side, negative 48 divided by negative 6. But since we're dividing both sides by a negative, we have to switch this inequality from less than to greater than. And then negative 6x divided by negative 6 is positive 1x is greater than positive 8 because negative 48 divided by negative 6 is positive 8. Okay, then write the interval notation. This is the algebraic notation. If x is greater than 8, the interval notation, parenthesis 8, comma, infinity. So these mean the same thing. One is in algebraic notation, the other one is in interval notation. And let's move on to the next one. This one, 3 times the quantity 4y minus 1 is less than 8y plus 13. Well, even though we could divide both sides of the equation by 3, it's not very convenient to do so because we introduce fractions if we do that. So in case you're wondering, up here, it was convenient to divide every term on both sides by negative 2 because after doing the division, we didn't have any fractions. We just had integers. So that governs why I sometimes will start out by dividing both sides by a number, and at other times I won't. If I introduce fractions by division, I usually want to avoid that, even though it's not wrong to do it that way. So anyway, the more efficient way to do it, in my opinion, is to start by multiplying 3 times the quantity 4y minus 1. So 3 times 4y is 12y, and then minus 3 times 1 is minus 3, is less than 8y plus 13. And in the next step, I will add 3 to both sides. So we get 12y is less than 8y plus 16. Then subtract 8y from both sides. 12y minus 8y is 4y, is less than 16. And then lastly, divide both sides by positive 4, and we get y is less than 4. Y is less than 4 is the algebraic notation for the solution. And the interval notation is parenthesis negative infinity, comma, 4 parenthesis. Okay, let's move on to the next one. Here we have 8 plus 6 times the quantity 3m minus 5 is greater than or equal to 2 times the quantity 8m minus 1. So how would you start? What would be the first step that you would take on this one?
Distribute the 6 and the 2.
Say that again?
Would you distribute the 6 on the left side and then the 2 on the right side?
Change this.
Yeah, so you just times 6 and 3m and then 5 and 6,
Can't tell what you're saying.
2. Sorry.
If you take your mask off, I might be able to read your lips.
Just multiply. So do 6 times 3m and then 6 times 5, and then do the same thing to the right side with the 2 and the 8m, and then -1 as well.
Yeah, that's a perfectly fine way to start. The suggestion was start out by applying the distributive property, multiply 6 times 3m minus 5, and then on the right-hand side, multiply 2 times the quantity 8m minus 1. Did someone have a different idea on how to start?
Could you add the 8 and the 6 first?
That would be illegal to add the 8 and 6. And the reason I was asking, in case there's that misunderstanding, I was hoping someone would bring that up. So remember the order of operations? We have to do multiplication before addition. So if we add 8 and 6 first, that is incorrect. We first must multiply 6 times the quantity 3m minus 5. So I know it's not easy to give an incorrect answer, but sometimes it's important that we get those things cleared up. So thanks for offering that suggestion. Okay, so let's, another option, which someone wrote on the YouTube's comment section, since 2 is a factor of all of the terms, 2 is a factor of 8, 2 is a factor of 6, 2 is a factor on the right-hand side, you could start out by dividing both sides by 2. Okay, but let's go ahead and we'll just start out by applying the distributive property on both sides. So on the left-hand side, we get 8 plus, and then 6 times 3m is 18m, and then minus 6 times 5 is minus 30, greater than or equal to 2 times 8m is 16m, and then minus 2 times 1 is minus 2. So on the left-hand side, let's combine like terms, the 8 minus 30. So 18m stays the way it is, and then the 8 minus 30 is minus 22. And then greater than or equal to 16m minus 2. So in the next step, let's subtract 16m from both sides. And when we subtract 16m from both sides, we get 2m minus 22 is greater than or equal to negative 2. Then we'll add 22 to both sides, and we get 2m is greater than or equal to 20, because negative 2 plus 22 is positive 20. And then lastly, divide both sides by 2, we get m is greater than or equal to 10. The interval notation, if m is greater than or equal to 10, we put a bracket that opens to the right, then 10, comma, infinity. Okay, the next problem, the next inequality, 8 times the quantity n minus 5 is greater than or equal to 8 plus 3 times the quantity 5n minus 2. So remember the order of operations. We must do the multiplication first before we add. So we'll apply the distributive property of multiplication over subtraction on both on the left-hand side and the right-hand side. On the left-hand side, 8 times n minus 5 is 8 times n minus 40. And then we have greater than or equal to 8 plus, and then 3 times the quantity 5n minus 2 is 15n minus 6. On the right-hand side, we can simplify further, so let's do that in the next step. So 8n minus 40 is greater than or equal to 2 plus 15n, because 8 minus 6 is 2. So now we can proceed in a couple of equivalent ways. Well, if you want to avoid negative coefficients of variables, you can. So one way to do it is to subtract 15n from both sides. If we do that, we'll end up with a negative 7n on the left-hand side, and that's fine. But if you want to avoid dealing with negative coefficients, you can. We can subtract 8n from both sides instead, if you prefer. So which one do you want to do? Well, not that you really want to do anything, but if you had to choose, which one would you choose?
8 out of 15.
Do what?
8 out of 15.
8 minus 15n, or 8n minus 15n? Okay, let's start by subtracting 15n from both sides. Be careful with negatives. So 8n minus 15n is negative 7n. So negative 7n minus 40 is greater than or equal to 2, because we also subtracted 15n from the right-hand side. The next step, add 40 to both sides. And so we get negative 7n is greater than or equal to 42, because we're adding 40. Okay, then what?
Divide.
Divide both sides by
Negative 7.
-7, and since we're dividing both sides by -7, switch the inequality to less than or equal. So I'll write this in a little bit more detail. 7n divided by -7 on the left-hand side, and 42 divided by -7 on the right-hand side. Since we're dividing both sides by -7, we have to switch the inequality to less than or equal. So less than or equal. No, it's easy to overlook if you're not careful. Negative 7n divided by -7 is positive n, positive 1n, less than or equal to -6, because 42 divided by -7 is -6. And then we write the interval notation for n less than or equal to -6. So that means parenthesis negative infinity, comma, -6, bracket. We use a bracket that corresponds to the or equal to part. Okay, on the next page, more of the same. Okay, on this one, 3/5 times b minus 1/2 times b is greater than or equal to 1/5 times b minus 1/2. Well, my preference to start with, since we're dealing with coefficients that are fractions and a constant that's also a fraction, I want to find the least common denominator or the least common multiple of the two different denominators, 5 and 2. The least common multiple of 5 and 2 is 10. So we can get rid of the fractions if we multiply every term on both sides by 10. Okay, so we'll multiply every term on both sides by 10. Think of 10 as 10 over 1 if that helps. Okay, so on this one, 10 over 1 times 3 over 5 times b, that's 30 over 5b, or 6b. And then we're subtracting 10 over 1 times 1/2 b, which is 5b. And this is greater than or equal to 10 over 1 times 1 over 5b, that's 2b, 2 times b. And then minus 10 over 1 times 1/2 is minus 5. So at least to me, I don't know about you, but this looks much easier than what we started with. 6b minus 5b is 1b, or just b. b is greater than or equal to 2b minus 5. On this one, I'm going to add 5 to both sides. So we get b plus 5 is greater than or equal to 2b. And then subtract b from both sides. And we get 5 is greater than or equal to b. Okay, so 5 is greater than or equal to b. It might seem more natural to have the letter B on the left-hand side instead of the right-hand side. And we can do that. If 5 is greater than or equal to B, what is that equivalent to if I want B on the left-hand side instead of the right-hand side? So inequalities can be read from left to right or right to left. Well, you know, even equations can be written or can be read from right to left. So if 5 is greater than or equal to b, reading it from right to left, what does that mean? B is less than or equal to 5, right? If we read it from right to left, b is less than or equal to 5. Are we in agreement? So if you want, you can write this as b is less than or equal to 5. These mean exactly the same thing. Is there any question about why that's the case? Well, let's consider the number line. If we put the number 5 and if 5 is greater than or equal to b, then on what side of the number line would the numbers b have to be on? If 5 is greater than or equal to b,
The right side.
yeah, then b is on the left side, right? Or it could be 5. That make sense? Because 5 is greater than or equal to b, 5 has to be to the right of b or possibly at 5 itself. And then b is less than or equal to 5 means the same thing. B is to the left of 5. Still any confusion about that? Okay, we're almost out of time. Anyway, the interval notation, if b is less than or equal to 5, it's negative infinity, comma, 5 bracket. If we, I have a few seconds. If we are here, b plus 5 is greater than or equal to 2b. And if instead we subtract 2b from both sides, b minus 2b is negative b plus 5 is greater than or equal to 0. Then subtract 5 from both sides, negative b is greater than or equal to negative 5. And then divide both sides by negative 1, we get b is less than or equal to positive 5. You can do it that way instead if you want. Okay, we're out of time, so if you're online, go ahead and type your first name followed by your last initial for attendance. Victor. Ammon Cole. Porter Hill. Porter. Nicholas. Calvin Hanks. Melissa Jones. Anthony Colt. Michael Montoya. Richard Ben. Did I get everyone's name? Oh. Bailey. Yeah. Now I have everyone's name.